Hello, I'm Diary, a master's course of GTM Lab. The paper I'm going to review today is Innovation Technology Opportunity Identification of Civil Aircraft Mechanical Connections based on generative topographic mapping. First, the bibliographic information of the paper. The paper was published in the journal Plus One in 2023, and the keyword and highlights of the paper are as follows. The table of contents for the presentation is as follows. Civil aircraft manufacturing is a strategic industry that reflects national competitiveness and generates significant industrial spillover effects. In this industry, mechanical connections technology is a core process, accounting for over 70% of aircraft structural connections and directly affecting quality, cost, and production efficiency. However, existing studies mainly focus on incremental improvements, highlighting the need for systematic identification of future innovation opportunities. Therefore, there is a clear need to systematically identify technological innovation opportunities in mechanical connection technologies. To address this gap, the study proposes a data-driven framework that integrates patent and academic paper data using LDA, TF-IDF, and GTM to identify underexplored or emerging technological areas and support strategic R&D planning. LDA is an unsupervised topic modeling method used to identify latent themes in large-scale text data. It has been widely applied to analyze academic papers in patent for topic identification and trend analysis. However, LDA alone can produce noise or less informative keywords. To address this limitation, this study combines LDA with TF-IDF to extract more representative technical keywords. Early studies on technology opportunity identification mainly relied on qualitative, expert-driven approaches, while are often subjective. To overcome this, quantitative and data-driven method has been introduced, but most studies still rely on patent data. Therefore, combining patent and academic paper data is considered a more effective way to identify latent innovation opportunities. Generative topographic mapping, or GTM, is a probabilistic method that visualizes high-dimensional data in a low-dimensional space. A key advantage of GTM is its inverse mapping capability, which allows technology blank dots to be interpreted using original technical keywords. This makes GTM particularly suitable for identifying technology vacuums and emerging innovation opportunities. This framework integrates patent and paper data to identify technology topics, visualize them using GTM, and interpret technology blank dots through inverse mapping to discover innovation opportunities. In this step, LD topic modeling is used to identify major technology domains from patents and academic papers. Based on these domains, TF-IDF is applied to extract representative technical keywords. These keywords are converted into binary vectors and used as input for GTM-based technology mapping. GTM projects technical keyword vectors onto a technology map where technology blank dots indicated potential innovation opportunities. GTM inverse mapping is then used to translate these blank dots back into meaningful combinations of technical keywords. Through this process, latent technological innovation opportunities are systematically identified. Mechanical connection technology is so critical in aircraft manufacturing, yet existing solutions remain insufficient. To identify innovation opportunities, they collected papers and patents related to aircraft mechanical connections from Web of Science and the Rund. The dataset covers the period from the year 2000 to 2022 and serves as the basis for the empirical analysis. This slide explains how the data were processed and how technical topics were identified. First, the collected patent and paper datasets were cleaned and pre-processed to ensure analytical consistency. Then, LDA topic modeling was applied separately to patents and papers to identify major technical topics in aircraft mechanical connection technologies. The optimal number of topics was determined using complexity analysis, and 7 topics were selected for both datasets. Finally, the identified topics were labeled with the support of domain expertise, forming the basis for subsequent innovation opportunity analysis. This slide presents a GTM-based technology map constructed by integrating patent and academic paper data on aircraft mechanical connections. High-dimensional technology data are projected onto a 21 by 21 grid, allowing us to visualize the overall technological landscape. Empty areas in the map represent technology market dots, which indicate potential innovation opportunities. Compared with patent-only maps, this integrated map provides a more comprehensive view of technological gaps and emerging areas. This slide summarizes innovation opportunities identified in academic papers but not yet patented. These opportunities represent combinations of technology rather than isolated keywords and may related to early strategic research areas. Firms can leverage these paper-only technologies to explore new R&D directions and gain first-mover advantages. This slide shows technology breakthroughs identified on the GTM map and interpreted through inverse mapping. The resulting 10 opportunities mainly point toward intelligent, integrated, and sensor-assist mechanical connection technologies. This slide summarizes the application analysis at different levels. At the research institution level, GTM inverse mapping helps identifying promising research direction. At the enterprise level, paper-only technologies support proactive patent planning and reduce R&D uncertainty. At the industry level, technology appearing in both papers and patents represent major hotspots for strategic investment. This slide summarizes the theoretical and practical implications of the study. Technology blank dots identified through GTM indicate underexplored or emerging technological areas. These results support targeted R&D and patent strategies at the organizational level. Overall, integrating patent and paper analysis with GTM provides a systematic framework for strategic decision making and technological innovation. To conclude, this study proposes a data-driven framework that integrates patent and academic paper data to identify technological innovation opportunities. By applying LDA, TF-IDF, and GTM, the framework visualizes the technology landscape and interprets technology blank dots as future development direction. The results highlight trends toward intelligent, integrated, and sensor-assist mechanical connection technologies. Overall, this study provides differentiated strategic implications for research institutions and industry and demonstrates the effectiveness of GTM-based patent paper integration for technology strategy. This is end of the presentation. Thank you for listening.